In this class, now I am going to discuss with you basic integration applications. See the first one, integral of e power x into sin x plus cos x dx. To answer this question, here we have one standard integral formula. See that standard integral formula, e power x into f of x plus f dash of x dx. If the function is given like this, e power x of f of x, whose integration is given here. Whenever the function is given like this, whose integration will be e power x into f of x plus c. Here, with the help of this standard result, I am going to answer this question as e power x. So, the differentiation of sin x is cos x. Hence, whose integration will be e power x into sin x plus c. See, compare this one with the standard result. So, here, let us consider this is f of x and whose integration is given here, cos x. Hence, whose differentiation is given here. Hence, whose integration will be e power x into sin x plus c. Now, let us go to other application. Now, integral of e power x into 1 plus x log x by x into dx. Now, how do we answer to this question? See, here e power x. Now, divide this x with these two terms, so that here what do you get? Here x cos x, x log x by x, x cancel, log x will come, here 1 by x into dx. Now, compare this one with standard result. So, here consider this is f of x, and as we know, whose differentiation is 1 by x. Now, the differentiation of this function is given beside of it now. So, before this here e power x is there. Hence, whose integration will be e power x into log x plus c. Even this one also I have answered by the standard result. Integral of e power x into bracket of f of x plus f dash of x is equal to e power x into f of x plus c, no? So, here by that standard result, it can be written as e power x into log x plus c. Next, integral of e power x into 1 plus tan square x plus tan x into dx. And now, how do we answer to this question? See, students, e power x. So, this tan x I would like to write as it is, but in the place of 1 plus tan square x, I want to write it as secant square x. You know that standard identity in trigonometry, secant square theta minus tan square theta equal to 1. So, secant square theta can be written as 1 plus tan square theta. So, here 1 plus tan square x is there. So, in place of that, you can write secant square x. Okay. Now, compare this one with that standard integral formula. So, let us consider this is f of x. And whose differentiation is secant square x is there. Hence, whose integration will be e power x into f of x. What is f of x here? Tan x plus c. Right. Now, let us go to one more application based on this same standard result. So, integral of e power x into secant x plus secant x into tan x into dx. Now in this application also it would be considered as f of x, and this will be f dash of x. Differentiation of secant x is secant x into tan x, no? Hence whose integration will be e power x into secant x plus c. Right. Now let us go to one more application. See this, integral of x into e power x by x plus 1 whole square dx. Now how do we answer to this question? See students, here I am making some adjustments in the numerator. This e power x I would like to write as it is, but in the place of x I would like to write x plus 1 minus 1. Can we write? Yes. Just here I have added plus 1 and I subtracted. Why means you will come to know in the next step. So now in the next step, e power x by here there are two terms. Now it should be written as x plus 1 by x plus 1 whole square. X plus 1 whole square, and here minus 1 by x plus 1 whole square dx. Okay, so here x plus 1 by this, now minus 1 by this. In the next step I would like to cancel this x plus 1. Now in the denominator there are two x plus 1s, and in the numerator 1 x plus 1. 1 x plus 1, 1 x plus 1 get cancelled. So then after that, integral of e power x into bracket of 1 by 1 plus x minus 1 by 1 plus x whole square dx. Okay students, so here as we know, the differentiation of this will be this. So let us consider this is f of x, and whose differentiation is minus 1 by 1 plus x whole square. How to determine the differentiation of 1 by 1 plus x? You know. So here 1 plus x whole power minus 1 you have to write. It looks like x power n. Then whose differentiation will be minus 1 into 1 plus x whole power minus 1 minus 1. Now simplify. Minus 1 by 1 plus x whole square will come. So hence whose integration will be, here the differentiation of this function is available beside of it, hence whose integration will be e power x into 1 by 1 plus x plus c. Okay, I hope you have understood. In the first step what did I do? Just I have added plus 1 minus 1. In the next step, so I divided this one into two terms. So here x plus 1 by x plus 1 whole square, here minus 1 by 1 plus x whole square. Here then in the denominator there are two x plus 1's, one I cancel with numerator, so this will be left. Now the differentiation of this one is given beside of it, hence whose integration will be e power x into 1 by 1 plus x. Right. Now one more application. Integral of 1 by 1 minus x square plus 1 by 1 plus x square dx. Now students, see here integral of, now 1 by 1 minus x square dx plus integral of 1 by 1 plus x square dx. Now you know integration is nothing but inverse process of differentiation only. So here the integration of this function will be tan h inverse of x. When you do the differentiation of this function, we will get 1 by 1 minus x square. Okay, so hence the integration of this 1 by 1 minus x square will be tan h inverse of x. As you know, the differentiation of this function will be tan inverse of x plus c, because the differentiation of tan inverse of x is this one. No, when you find whose integration, we will get tan inverse of x. Right. Now let us go to one more application. See here, integral of dx by x plus 1 into x plus 2. Students, see here how the denominator is looks like. So denominator contains two non-repeated linear factors. So in this type of applications, you would have to apply partial fractions. See, first split this rational fraction into partial fractions. So here a by x plus 1 plus b by x plus 2. Now take cross multiplication. So 1 by x plus 1 into 1 by x plus 2. So which is equal to a of x plus 2 plus b of x plus 1 whole by x plus 1 x plus 2. So cancel these two. Now obtain this a and b value. To get a value, I would like to write x equal to minus 2. When you put x equal to minus 2, left side there is no x. So that write 1 as it is, and here this becomes 0. And what about this? B of minus 2 plus 1, which becomes minus 1. Now your b will be minus 1. Now to get a b value, to get a value, you would have to make this b value as 0. So for that, I want to put x equal to minus 1. When you write x equal to minus 1, left side will be 1. So this part becomes 0, minus 1 plus 1. And here minus 1 plus 2, which becomes a. Now you got a value is 1, b value is minus 1. Now replace, so this rational fraction by this. So here a value, how much have we got? 1. Then 1 by 1 plus x dx will come here. Now b value minus 1. Minus 1 I would like to write outside. Here 1 by x plus 2 dx. Okay. So in the next step, find whose integration. As you know, this is standard result, f dash of x by f of x dx. If the differentiation of denominator is available in the numerator, hence whose integration will be log mod f of x plus c. Okay? If the differentiation of denominator is available in the numerator, hence whose integration will be log mod f of x. So here observe, the differentiation of this denominator is 1. Hence whose integration will be log mod 1 plus x minus, and here also whose differentiation is there in the numerator, hence whose integration will be log mod x plus 2 plus c. Now see here, you know, log a minus log b can be written as log a by b, log x plus 1 by x plus 2 plus c. Okay students, right. Now let us go to one more application. Right, see this, integral of secant square x into cosec square x. Integral of secant square x into cosec square x dx. Now how do you answer to this question? First express them into sin and cos. This can be written as 1 by cos square x, and it should be written as 1 by sin square x dx. In the next step, in the place of numerator, what is there? 1. So now it can be written as sin square x plus cos square x whole by cos square x into sin square x dx. Now, in the numerator there are two terms. Divide these two terms by this. When you divide this by this, sin square cancel. So 1 by cos square x dx will come. And here cos square x cancel. 1 by sin square x dx. You know, 1 by cos square x can be written as secant square x dx. Now 1 by sin square x can be written as cosec square x dx. You know the integration of secant square x, tan x. Next, integration of cosec square x minus cot x plus c. Now your required answer will be tan x minus cot x plus c. First, what did I do? I transformed this one into the sin and cos. So here in the numerator 1 is there. That 1 I have written as sin square x plus cos square x. In the next step I divided these two terms with this so that I got this. Now as you know, 1 by cos square x is nothing but secant square x and cosec square x. We have standard integral formulas for those two. Integral of secant square x is tan x. Integral of cosec square x is minus cot x. Right. Next, see. Let us go to one more application. Integration of 1 by 1 plus cos x dx. 1 by 1 plus cos x dx. How do you find whose integration? Integral of 1 by 1 plus cos x. Now, numerator and denominator. So, multiply with 1 minus cos x by 1 minus cos x dx. Right? Now, integral of 1 into 1 minus cos x. 1 into 1 minus cos x. 1 plus cos x, 1 minus cos x. Can be written as 1 minus cos square x dx. Are you getting me, students? Now a plus b into a minus b can be written as a square minus b square. But you know 1 minus cos square is equivalent to sin square x. Now integral of 1 minus cos x whole by sin square x dx. Now in the next step, 1 by sin square x dx minus integral of cos x by sin square x dx. Now integral of 1 by sin square x can be written as cosec square x dx minus here sin square x, split it as sin x into sin x. So here 1 by here cos x by sin x can be written as cot x and 1 by sin x will be there. So that can be also written as cosecant x. Finally, if you simplify this, so it can be written as cosec x into cot x plus c. Okay, here sin square x is there now, that I have written as sin x into sin x, but here cos x by sin x, which can be written cot x, and one more sin x will be there, that 1 by sin x also can be written cosec x. So now hereafter apply that standard integral formulas. So integral of cosec square x is minus cot x, and here integral of minus cosec x into cot x can be written as plus cosec x plus c. You know, students, here cot x differentiation is minus cosec square x. Minus into minus plus. Cosec square x is getting now, and go to this one. Differentiation of cosec x is minus cosec x and cot x is there. So when you find whose integration here, minus of cosec x into cot x is there now, then whose integration will become plus cosec x. And here integral of cosec square x is minus cot x will come. You know, so when you differentiate it, you would have to get this back step. Matching, no? Hence, whose integration will be this much, minus cot x plus cosec x plus c. Right? Now, let us go to one more application. Integral of 1 plus cos square x by 1 minus cos 2x dx. And now students, tell me, how do we find whose integration? See here, integral of 1 plus cos square x by what is there in the denominator? 1 minus cos 2x. You know that multiples formula. So this 1 minus cos 2x can be written 2 sin square x. So in the next step, this 2 I would like to write outside. Now it can be written as 1 by sin square x dx plus 1 by 2 of cos square x by sin square x dx. Now you know 1 by sin square x can be written as cosecant square x cosec square x dx plus cos square by sin square can be written as cot square x. So here 1 by 2 of cot square x dx. Now in the next step, so this 1 by 2 I want to write outside bracket of integral of cosec square x dx plus, now this cot square x can be written as cosec square x minus 1 dx. Okay, because we don't have standard formula for integral of cot square x. So that I have transformed this one into cosec square x minus 1. You can, you know, we have one standard identity in the trigonometry, but by that standard identity, so it can be written as cosec square x minus 1. So in the next step, students, see here 1 by 2 of integral of here cosec square x, here cosec square x. Now both will be like terms, no? When you add them, 2 of integral of cosec square x dx minus 1 into dx. Now right here 1 by 2 of 2 into integral of cosec square x is minus cot x. Minus cot x, integral of 1 dx will be x plus c. Now simplify this. So here 2 will be get cancelled. Minus cot x minus x by 2 plus c will come. Okay? Right. Now let us go to one more application. Right? Integral of sine of log x by x into dx. Now, how do you answer to this question? It is going to be done by substitution method. So here, substitution is log x equal to t. Now differentiate on both sides with respect to x. Now, whose differentiation will be 1 by x, and this is dt by dx. When you take dx left side, 1 by x into dx, which is equal to dt. Now here 1 by x dx equal to dt. Now integral of sin t dt. Now integral of sin t is, you know, minus cos t plus c. In the final step, replace this t by log x. So minus of cos log x plus c. Okay, students, I hope you have understood this application. Now let us go to one more. Integral of cot of log x by x into dx. Cot of log x by x into dx, same like previous one. Let us take log x equal to t. Now differentiate on both sides with respect to x. Now 1 by x equal to dt by dx. Now when you take dx left side, 1 by x into dx equal to dt. Now cot of log x value is t. Now cot t into dt you will get. Log x value t now students. Then cot of t into dt. You know integration of cot x, log mod sin x. You know that standard integral for cot x. Cot x integration is log mod sin x. So here log mod sin t you will get plus c. Now t is nothing but here log x. Log of sin of log x plus c. Right. Now let us go to one more application. See this integral of 1 by x into log x dx. See here integral of this 1 by x I would like to write in the numerator by log x dx. If you would like to apply direct standard formula you can, otherwise consider log x equal to t. Okay, so here as I said to you, f dash of x by f of x dx is equivalent to log mod f of x. Use that standard result. So as per that standard result, it can be written as log mod log x plus c, because the differentiation of denominator is given in the numerator, hence whose integration will be log mod log x. Right. Now see the next application. Integral of 1 by x log x bracket of log x dx. Now students tell me, even this one also we are going to answer by substitution. Now let us take this log of log x is equal to t. Now differentiate on both sides with respect to x. Consider this one as x. Now log x differentiation is 1 by log x. Is this x? No. Whose differentiation is 1 by x? Again we have to follow the chain rule. Differentiation of log x is 1 by x, but this is not x. Hence we have to go for differentiation. Whose differentiation will be 1 by x. Now which is equal to dt by dx. Now bring this dx to the left side. 1 by x log x into dx, which is equal to dt you will get. Okay students. Now here 1 by x log x dx. In place of that we have to write dt. And this one we have taken as t, no? Hence 1 by t dt will come. As you know, whose integration will be log mod t plus c. Now t is nothing but log of log x. Replace this t by log of log x plus c. Okay students. Right. Now let us go to one more application. right? See this integral of log of 1 plus x by 1 plus x dx. Now how do you find whose integration? So this one also we are going to answer by substitution method. What is the substitution here? Log of 1 plus x equal to t. Now differentiate on both sides with respect to x. So that here you will get 1 by 1 plus x, now which is equal to, differentiation of log x is 1 by x. Is this x? No, follow the chain rule. 1 differentiation 0, x differentiation 1. Now here dt by dx you will get. Now bring this dx to the left side. 1 by 1 plus x dx, now which is equivalent to dt. Now go here. 1 by 1 plus x dx can be written as dt, and now it is taken as t, no? Now write here t into dt. Now find whose integration? T square by 2 plus c you will get. Now t is nothing but what? Log of 1 plus x. Log of 1 plus x whole square by 2 plus c. Log of 1 plus x whole square by 2 plus c. Okay? Alright. Now go to one more application. Now tell me, how do we do this? Integral of log x whole square by x into dx. Tell me students, how do we answer to this question? Now tell me, how do we answer to this question? Log x whole square by x into dx. Let us take, now log x equal to t. Now differentiate on both sides with respect to x. Now 1 by x which is equal to dt by dx. Bring dx to the left side. 1 by x dx equal to dt. Now here it is going to be t square dt. Now t square integration t cube by 3 plus c. Now t is how much? Log x whole cube by 3 plus c. Log x whole cube by 3 plus c. Right. Now let us go to one more application. Integral of sine of tan inverse of x by 1 plus x square dx. Now see students, let us take tan inverse of x which is equal to t. Now differentiate on both sides with respect to x. So if you differentiate on both sides with respect to x, here 1 by 1 plus x square which is equal to dt by dx will come. Bring dx to the left side. 1 plus x square dx equal to dt. Right. Now see, okay, here we have taken this one as t now. Now replace this one by t. Now sin t. So dx by 1 plus x square can be written as dt. Now you know integral of sin t dt which is equivalent to minus cot t plus c. So now minus cos of t value tan inverse of x plus c. Right. Now for this basic integration I take one more class, and in next class I will explain you some more applications from this basic integration. Thank you.